In Lesson 1, Part 1, we looked out at the horizon, observed that it appeared flat, and with that observation, we formed the hypothesis that the Earth is flat. On the other hand, some people have gone out and observed the horizon and have seen curvature. With that observation, using the same reasoning, they are able to form a rivaling hypothesis that the Earth is a globe. Alright, so now that we've got two rivals, let's put our hypotheses to the test and see which is stronger. First, let's go take a closer look at this observation so we can see what we are up against. This observation comes from mctoon.net. mctoon is an anti-flat earther whose entire website is dedicated to combating the flat Earth hypothesis. He also has a YouTube channel dedicated to the same thing. Just so you know what you're looking at here, the red bars are simply just straight edges. They are meant to be a control in the experiment, representing a standard of flatness. Now, just basing it off of this observation alone, it looks pretty flat. But that isn't what he's basing his globe Earth hypothesis off of. Since the Earth is so big, he doesn't believe we would see much curvature this close to the surface. But he believes that if he scrunches the photo horizontally, it will reveal the hidden curvature of a globe Earth. Alright, here we are back at his website. I'll go ahead and scroll down here. There's his image. There we are a little bit more zoomed in. And this is where he has compressed his image horizontally. And lo and behold, we can see curvature. Here, I'll do the same thing for you so you can see what he did. Alright, this trick is really simple. All you do is select the horizon between the two beams, and then you grab it by the corner and scrunch it really quick. And then we can take a closer look here. Oh my goodness! You can see the curvature of the Earth! Or do we? Let's try this on the other side here. Okay, select it. Scrunch it. And take a closer look. What? Where's the curve? Why in the world is it curved on one side, but not curved on the other? I actually went and talked to mctoon about this, and he still thinks the right side is curved. So let's take this to the next level and measure this thing. This time, we are not going to scrunch the photo. We are going to measure the unscrunched photo so there can be no dispute about the scrunching process distorting the photo or the camera being tilted or anything like that. First, I'm going to sharpen this image by adjusting the brightness and contrast. This will make things easier to count the pixels as we measure the rate at which the horizon appears to curve. Alright, now here you can see I have measured it out to be just over 200 pixels. And here is where we can observe that this portion is all flat within 2 pixels. Let's continue on now, doing the same thing. Just zoom in here. Alright, now we'll adjust the brightness and contrast. Okay, now here I've measured it out. 100 pixels, 200 pixels, 300 pixels. And as we zoom in here, we'll see that it's gone up a pixel. So our rate of curvature is 1 out of 300 pixels. Now we're starting over. 200, 300, but it's still straight, so we'll continue on. 400, 500, oh, now it's moving up. So our new rate of curvature is 1 out of 513. Starting over, 100, 200, 300, 400. And as we see, it's kind of in the middle of the beam, but it's still straight, so we'll keep going. 600, 700, 800, 915. We're definitely seeing curvature here, but it's curving at an uneven rate. Now, the brightness and contrast got a little messy over here on the right side, so we'll go ahead and readjust that so we can get an accurate measurement. Alright, here's that brightness and contrast. Looking much better now. It's still a little bit messy, but it's not too much to be worried about. It'll still work. Now, here you can see that I didn't number out the pixels this time. It was unnecessary because, as you can see, we can go all the way across this entire section and see that it is all flat within 2 pixels. So we saw an inconsistent amount of curvature on the left side of the photo, but on the right side we're not seeing any curvature at all. What is going on? Many globe earthers claim that because curvature was present, that automatically means the curvature was caused by a globe earth, and that utterly destroys the entire flat earth hypothesis. But if that curvature was being caused by a globe earth, why was it so inconsistent? And why did it appear flat on the right side? It seems both hypotheses have a problem to deal with here. The flat earth has to explain the curvature, and the globe earth has to explain the inconsistency of that curvature and the lack of curvature on the right side here. So, what could be causing the appearance of this curvature on a flat earth? Here's a little something to remember. The moisture content and density of the air is not perfectly uniform. If the atmosphere is thicker on the left than it is on the right, then we won't be able to see as far on the left as we can on the right. And that is going to cause the horizon to appear to curve. In a way, the atmosphere on the horizon can act like a tree line. Here our tree line appears to curve in the grass because those trees on the left are closer to us than those trees down in the middle. Here's a nice condensed example of what I'm talking about. Here we can't see as far on the left as we can on the right. And that's causing a curve down in the grass there where the fog meets the grass. Here, I'll go ahead and draw that in for you. Going across, it goes up, and then it levels out again. Now let's go ahead and scrunch other horizons and see what happens. Okay, select. Scrunch. Okay, let's zoom in and I'll move over for you. Huh. Look at that curve. Are you going to say that was the camera being tilted? Is that lens distortion? I don't think so. Pretty sure that's the atmosphere. Ooh, here's a nice pretty one, taken from above the clouds. Select. Scrunch. And does that look like it proves that the Earth is a globe? No, it just proves clouds are uneven. Let's try this one. It looks like it was taken from a plane, and a lot of people claim to see curvature from planes. Select. Scrunch. Where's the curvature? Ah, I love this one. All right, select. Scrunch. Whoa! Look at that. Okay, well, the camera probably wasn't perfectly level on that one. I can see that, but it still looks pretty flat. Alright, so we can fully acknowledge that we can sometimes see curvature on the horizon. But does that mean the Earth is a globe? No. Other things can most certainly cause the horizon to appear curved. Curvature does not equal globe. And because horizons still generally appear flat, our hypothesis still stands. But now it has additional fortification because of our further observations. In other words, our hypothesis has withstood this test. Thank you all for watching. If any globe earthers would like to explain these uneven amounts of curvature, or the flat horizons that we saw, I will allow you to do so in this comment section, so long as you can be respectful and maintain a friendly demeanor. Though, I would really love to see your explanations on our debate board. There's a link to that down in our description.